and see how it goes.
All right, guys.
Okay, so what are the constant terms on the left side? So you equate these coefficients to be 5. Does that make sense?
Okay.
So now you have a system, 2 equations, 2 unknowns, so you're able to solve that. You can solve that with elimination or addition method, substitution, or a matrix. I would recommend you just use a matrix. Do you remember how to change this into a matrix? Right. So they're all in order. So if the constants are on the right, the variables are on the left, the first column will be the A column. So we have 1A and negative 2A. The next column will be 1B, 3B. The augmented part is the constant. This is back from college algebra. If you prefer elimination or something else, that's totally fine. But I recommend this guy because you can set it up and then use your calculator to solve it, or use a matrix solver online. It's supposed to be a tilde. Do you guys have a TI-84 by chance, or something similar? If not, I'm gonna send you a link. You're not required to buy that, by the way.
Can you repeat that? You're kind of far away.
Yeah, can you, do you have a TI-84 or 83 or 89 calculators? If not, it's okay.
I have 84.
84.
All right. Here's a link to a solver that I think is pretty easy to use. I mean, there's tons of them, but I figured this one was really easy to use. So we have 2 rows. So this is a 2 by 3 matrix. We have 3 columns. It's always row by column. The way I remember it is RC Cola, right? Row, column. 2 rows, 3 columns. Okay. Maybe we can go through the steps and solve it, but at this point, it's not a huge deal. So 1, 1, 0, negative 2, 3, and 5, and then just have it solve it for us. So remember, our x1 is A, right? x2 is 1. So in a matrix, if you were to do this by hand or your graphing calculator, it's going to give you this output. Let me switch back. We're going to say 0, 1, or 1, 0, and the constant, the answer, negative 1. 0, 1, and your answer, 1. And if you were to do it with your TI-84 or 83 or whatever, let's see if I can put it in here somewhere. Second, and then the inverse button, matrix, go to edit, choose the dimensions, 2 by 3, and then you enter the values. So I guess I did this earlier. 1, 1, 0, negative 2, 3, 5. So just enter them in there, and then quit. Once you've done that, you go back into the menu and go to math. All these math operations are used for matrices only. So go down all the way to the bottom to find RREF. This is called row reduced echelon form. All that really means is this, as 1001. They have one along the main diagonal. That's all that means. Again, you don't have to use this if you want to. I think it's pretty straightforward. So you get your answers. So A is -1 and B is 1. So you can use your calculator, you can use an online solver, you can also use elimination, doing it by hand, or substitution. It does not matter how you do it. I recommend matrix because it's easier. Easier once you learn how to use it anyway. So A is -1, B is 1. So that means 5 over x plus 3 times x minus 2 is equal to -1 over x plus 3 plus 1 over x minus 2. So that is the answer. This guy here.
I have a question about the TI-84 inputs.
Mhm.
Once you have the matrix set up, like how do you make it solve the matrix?
So once you have it in there, you quit and go back to the main menu, and then go second X inverse to get back to the matrix menu. Go to math. Math has all the matrix operations. So go to the bottom and find RREF. So press enter on RREF, and then it's going to wait for a matrix. So you go back and get the matrix. So under names, just press enter on the one you want to solve. And then you press enter. That's it.
And the solution is always the right-hand side, I guess. Of the,
Yeah, remember what was the goal, right? We're trying to separate these fractions and find the numbers that make it true. And it's going to be these guys. That was the whole point of this.
gotcha.
I know it's something we forget while we're doing this, right? I feel like 20 steps. What am I doing? Although this technique is not useful until calculus 2, which is a shame. But you'll see what I'm talking about if you're going that far. Any other questions on case 1? So right here. A system of equations using the technique equating the coefficients. All right. So let's solve the same question using the other method. And I'm sure you'll like the other one, but just remember, you're going to need both, not just one. If you only want to learn one, then learn this guy. Okay? I'm going to turn the page. You guys cool with that? I'm going to do the same question with a different method. All right, so let's find a PDF. Yeah, since you got -1 plus 1. All right. So we're going to start here. Case 1, using Heaviside method.
Can't see your handwriting.
Nope, yeah, sorry.
There we go.
So I'm going to start from here. So we've done this problem almost 3 times, kind of. So we factored it, we separated it and set out the problem, right? So we started. Then we multiply both sides by LCD, right? So we multiply both sides by x plus 3, x minus 2, which ends up giving us 5 equal to a times x minus 2 plus b times x plus 3. So I'm going to skip the step we've already done. Okay, is that cool with you? So what you do is you let x be equal to anything that is helpful. So if I let x be 2, notice how this part will vanish, right? And then I can solve for b. So I'm going to say let x equal 2, and see what happens, right? 5 equals a times 2 minus 2 plus b times 2 plus 3. So notice how this is 0, right? That's going to be gone. So when that is gone, we will be left with 5 equal to 5b. Do you agree with that?
Okay.
So solve for b. What is b?
B is 1.
Yeah, which we already knew, right?
Uh-huh.
So the answer, b, is 1. So see how it feels a little easier, right? But it's only easy when it works. Okay. So I prefer you have multiple tools for certain situations. So I'll leave that up to you though. So once you have b, yeah, what's up?
Sorry, how did you get b equal to 1? Sorry, I might have just lost.
No, you're good. So you understood how we got to here, right? This part made sense?
Yes.
So to solve for b, you have to divide both sides by 5. So they cancel, and you're left with 1 equal to b, right?
Yes.
So that's how you get b. Once you have b, plug that in, and choose a different number for x. What do you think is a useful number for x? Looking at this original problem here.
I don't know what you mean by useful.
Oh, when I chose x to be 2, I chose 2 for a reason. I wanted this to zero out. Because once it was gone, I could just isolate
Is it
b.
-3?
Yeah, that's the best option. There you go. So x is equal to -3. The b is going to vanish, so we don't even have to plug it in, but usually you should plug everything in. So 5 is equal to a times -3 minus 2 plus 1, right? Times -3 plus 3. So this is all gone. So now we have 5 equal to -5a. So divide by -5.
Your handwriting?
That's going to go. So these cancel, and you're left with -1 equal to a.
So can we use this method all the time, or it's either or, like depending on the problem?
This method is great when it's a simple problem. But you're going to see that there's some questions that using this method becomes a real headache, and it's not worth it. the homework will, when you click show me example or show me the solution, they're only going to do this method. They're not going to do the other one. The other method always works, and it's a little bit more straightforward. You just need to get used to it, which we're going to do the other one a bunch of times after this guy. But the heaviside method makes sense. So the answer would be the same thing, right? -1 over x plus 3 plus 1 over x minus 2. That's the goal. Find the A and B. Okay. One moment. Okay, so good. Let's do case 2 and solve every single piece. So I'm not going to use both methods. This is the repeated linear. Factors. Okay, so we started with this guy. And then we factored the denominators. So the factorization that we have already done was x times x minus 1 squared. Yeah, let me double check. Yep. You guys remember? Then we use the A for the linear distinct factor, and then we had to count up to the squared. So now we have to find ABC. All right, so step 1 is the same. Multiply both sides by LCD, which is going to be x times x minus 1 squared. It's always going to be what's down here in the bottom on the left-hand side. Okay, for these types of questions. This section, I mean. Okay, so here we go. I'm gonna write down both sides and multiply by that stuff. So times the LCD. Then each term times the LCD. So big 2 then, whatever. Okay, you guys read that? I kind of had to cram it in there. Notice on the left side, this is going to cancel everything. So pretty much every single time when you're doing partial fractions, the left-hand side will only leave you with this, the numerator. Okay. Then the x's will cancel, and the first term will only have x minus 1 squared.
Mm-hmm.
Now look at this guy. One of these will be canceled. So I'll be left with a single x and x minus 1. The entire x minus 1 is going to cancel, leaving me with cx. Okay. The downside of this method is you have to distribute things. So here we go. If I were to use the other method, let me just eyeball it real quick, see if it would be hard. Yeah, I think I could force my way through. Let x be 0, let's find this one. So let x be 1 and find c. Once I find a and c, I can let x be anything. I decided I would work on this guy, but we're not going to do it. Just letting you know. So FOIL or expand x minus 1 squared. So you're going to get x squared minus 2x plus 1. And let's get the FOIL there. But remember, if you square something, you have to multiply twice, right? Plus d times distribute the x times x times 1. Then just distribute and collect the like terms, just like we did before. So that will be ax squared minus 2ax plus a plus bx squared minus bx plus cx. So next step, we'll collect like terms, then factor and create the system of equations using equate to coefficients. Okay. So just gather everything that's the same power, put them together. That's all we got to do. So there are two quadratic pieces. There are 1, 2, 3 first power pieces, and there's one constant by itself, which is good. That means that will be easy to solve. Ax squared plus bx squared minus 2ax minus bx plus cx. So there's all the quadratic terms, all the linear terms, and then the constant. Make sure the signs are good. Yeah, okay. So here we factor, just so it's more obvious. And I factor on the right side just because I want you to see that these are coefficients. I know it's weird, but it'll help. I'm factoring the x on the right side. Okay, once you get to here, you can create the system. So look at the quadratic part. A plus b equate this to the left-hand side, is there a quadratic term over here?
No.
No, so you're going to set this coefficient equal to 0. Now look at the linear terms. Negative 2a minus b plus c. This is equal to, is there a linear term on the left-hand side?
2x.
Yeah, so you set it equal to the coefficient. That's why it's called this. All right, there's only one constant. A is,
3.
Yeah.
-3.
so you actually solved A already just by plugging it in. So I have A. What does B have to be in order to get this to be 0? If A is -3.
3. +3.
Yeah, right. So you got B too. If you have A and B, what is C?
The hypotenuse.
Looks like it, right? So that'd be what, 6? Let's see. Yeah, go ahead and plug it in. Okay, so did everyone see where we got the B from? I know I skipped a step there. Was that weird? All right, so it's clear that A is -3. So we'll call this 1, 2, and 3 equation. So for 1, if I plug in the answer for A, then you can solve for B, right? Adding B over, adding the 3 over. Once you have A and B, you can plug that into equation 2. And plug in, what's up? Where did I lose you? Here?
I think
Sorry.
someone just had an open mic.
Oh yeah, sorry.
Oh, I thought I lost you there. Okay, so we're taking the first equation, plugging in the number that we knew was true. This was kind of given to us. So there it is, -3 plus B. Add 3 to both sides and you solve for B. So that's where this came from. Once you have 2 of them, plug that into equation 2 for A and B. So we're going to have negative 2 times -3 minus 3. That looks horrible. Get it right at the bottom. -2 times -3 minus 3 plus C. So -2, -3, that is a 6. Subtract the 3. That will be 3 plus C equal to 2. Subtract 3 on both sides. That will give us C equal to -1. Right? Now, again, we said we can solve ABC in different ways. We can use matrix. We can use elimination. And what I did was kind of like a halfway substitution. But if we were to use, if we were to change into a matrix, we could just use our calculators, right? Not worry about this. But just you have to remember though, this is a 3-dimensional matrix, right? We have ABC. So the first row will be 1, -2, 1, so all the A's. The B's will be 1, -1, 0. C on the first one doesn't exist, so 0. 1 on the second one, 0 on the last one. And then solve this. So you can use the matrix, you can use this guy, doesn't matter. Right? So let's see if the calculator gives you the same thing. You can use your TI, whatever, it's not good. What is the dimension of this matrix?
2 by 3.
3 by 4.
Three rows, 4 columns.
Yeah.
So our answers, our values are 1, 1, 0, 0, -2, -1, 1, 2, 1, 0, 0, -3. All right. So we got -3 for A, 3 for B, -1 for C, right? Yeah. I'm not going to make you solve the matrix by hand because you did that already in college algebra. So I figure you should probably already suffered at that point a little bit. But again, you choose a method for solving for ABC. The equating the coefficients stops right here. It's just setting it up. Once that's set up, do what you want. Okay. So our answer, no, there are more steps. So your answer will simply be plug in your A, B, and C. So that will be in your homework. All they want is this part. Okay. On your test, I want to see your steps, right? You guys have any questions on any of these steps? In case 2. I'm hoping everyone's cool with the setup, right? And then we multiply by LCD. Once that happened, we got to here, no more fractions. We expanded it and collected the like terms here. Once we got there, we factored this stuff out and used equate the coefficients to make this system. Once you have the system, you solve it, and that's it. Okay, those are the main points.
Mhm.
You can see why I said this is pretty algebraic intensive, right? Plus 3. See if we have time for this guy. In quadratic factors, we started with this here. Then
Lost my pencil.
we use the bx plus c technique because it is a, oh no, I'm sorry. Yeah, that's right, sorry. Doubted myself for a second. Okay. So first step is the same thing, right? Multiply LCD both sides, expand everything, collect the same powers, and that's it. So multiply both sides by this. Okay. We know the left side would just be left with the numerator, but we're going to show everything anyway. selecting everything and just attaching this in front. Yeah, I just rolled it. Too small. Sorry, guys. Just remember, if you can't read this, I'm copying the exact same thing up here and just putting this in front, right? That's all I'm doing. Not new information yet. But, you know, now I can fit it in there. Should have made this guy smaller. Okay, so left-hand side going to cancel, leaving only the x. First term will cancel the x minus 1, leaving us with a times x squared plus x plus 1. On the last term, the x plus c is left with just the x minus 1. So all the fractions are gone. All right. So just my mic died, so I'm switching to a different mic. You guys can hear me, right? Okay.
Yeah, we can hear you.
So distribute the a, and then FOIL this guy, and see what happens. We have a x squared plus a x plus a. This requires a FOIL, so that will be bx squared minus bx plus cx minus c. Okay. Added the like terms. So ax squared plus bx squared. That's all the quadratic parts. Ax minus bx plus cx plus a minus c. I believe that is all the constant. Yeah, cool. Left-hand side only has one x, right? So what is a quadratic piece going to equal to?
AX.
A plus B.
After a while, you don't really have to factor. You kind of see what's happening, but I'm going to keep doing it. So the quadratic piece is equal to
0, right?
Yes.
X piece is equal to 1x, because there's 1 over here. And then the constant terms, there is none. So the matrix for this would be 1, 1, 1 for all the A's, 1 B here, negative B there, no B there, no C, 1 C, negative 1 C. Then the constants, 0, 1, 0.
Mhm.
Right. Here we're sharing the same thing again. Calculator is just fine too, but sounds good. Maybe we should do it with the calculator this time, just for fun. All right. The second matrix. What is the dimension of this matrix?
3 by 4.
So 3 rows by 4 columns, right? So edit 3 by 4. 1, 1, 0, 0, 1, negative 1, 1, 1, 1, 0, negative 1, 0. Quit. Once it's entered, it should be saved in A or wherever you chose to put it. Go to math, call REF function, go back to the matrix menu, choose the first one, and it's a bunch of fractions. That sucks. What you can do is hit second, or hit math and change it to fractions. It's a little prettier, right? Strange. Okay. Let me see if that's right. Yeah. Looks like we're good. Here's the PDF. You can see 1 over 3, right? That's the first one. Minus 1/3, that's the B term. And the C, 1/3. Okay. So the final answer would be just that. Plug in the ABC. So you write it down here. A is 1/3. B is negative 1/3. C is 1/3. So our answer will be 1/3 over this plus, it's not going to look pretty, but it's just how it is. 1/3 x plus 1/3. Okay. Is the equating the coefficients making sense? It's always going to be this way. And this technique will always work for you. That aside, again, it's cool when it works, but if you run into a wall, switch back to this guy, okay? And if you want to worry about the other one, then just use this one. Okay. Ready? I guess that's about it for this. It's really the same kind of thing. Yeah, I think we'll stop here. So on Monday,